Yes, thank you very much. And in this beautiful building, I have my working place. And regarding the stents and the in vitro systems, on the one hand, I have the critical urologist, on the other side, the scientists from the institutes. And I would like to address the question which in vitro incrustation models can be used to simulate condition in the urinary tract. In this context, I think on the relationship incrustation urolithasis, the standard of the art and new developments and requirements of the test systems. Many studies with urinary catheters and stents can be found in the literature. On one hand, in vitro test, on the other hand, clinical test. But the study results differed from another. Stiglitz says in the review, something needs to be done. What are the results of current research and clinical studies? Here an example of the often cited silver coating, a comparison of an in vitro study with a clinical trial. On the right side, Wakers et al. Shows that a silver release reduced the biofilm of E. coli bacteria in synthetic urine solutions, green marking. On the other hand, Picard showed in a study with more than 2,000 patients that silver coating shows no advantages. One consequence is coated catheter are currently not recommended by the urological societies. Why do the trial data different from laboratory studies predicted? This figure shows the illustration of a ureteral stent in the urinary stent environment. Ureterial tissue, stent, and urine with salt, bacterial cell, and biofilm. Diseases of the patient are the main reason for the ureteral incrustation. The figure shows examples of diseases that affect kidney function or urine composition. The resulting risk of urinary crystallization is significantly affected a healthy person. The most important types of urinary stone are calcium oxalate and calcium phosphate. Infectious stones have a share of only 6%, and more than 17% of stent incrustation correlated with stone composition. And here's a critical point. In contrast to these facts, most in vitro incrustation models use synthetic urines based on urease reaction and simulated an infection situation. And there are natural defense mechanisms in the urinary tract, such as urinary flow and TAM-Horsford glycoprotein. Urinary stents have no protection against incrustation and infection and are the real problem. The incrustation is one effect. The second effect is catheter-associated urinary tract infection. Bacterial biofilm formation proceeds similarly to incrustation but much faster. Uropathogenic microorganisms are often introduced into the bladder when the catheter is inserted. From the bladder, bacteria ascend through the ureter and especially along the ureteral stent into the kidney. As you can see, the problem of urolithiasis and incrustation are very diverse. A simple test system is not realistic. One problem is the test medium urine. In artificial urine, we often find simple and homogeneous crystals. In contrast, in human urine, we find mixed stones of different size, different chemical and physiological properties. In addition to calcium oxalate, other substances groups are also precipitated, depending on the pH value, and such as calcium phosphate, and in an alkaline environment, magnesium ammonium phosphate dystrophy. And here's an example of incrustation in synthetic urine. In addition, standard and abstracted ureters show pathological response that are not fully characterized with a simulation. To be noted is effects on peristalsis and dilatation in the ureter. And here's a picture of your ureter dilatation following stent insertion in the animal model pig. In summary, it can be said that the requirements for the test systems are very high. Early design focused on the use of continuous flow systems such as the hemostat model, which had the advantage of fresh medium and constant volume. The hemostat reactor is essential for sampling testing, but less attractive for screening. This led to development of the static biofilm models with high throughput, the microteter plate system. I think that the flow systems are useful for testing prototypes. And the modified Robinson device, samples coupons are inserted into the liquid stream. The coupons consist of the test materials. Different modifications can be tested at the same time. And the microteter plate system is a closed system, a batch system. An important advantage is the simultaneous testing of large series under different conditions. The disadvantage is the static medium. A release or influence of active substances cannot be tested. And now the question, are there new in vitro systems? Yes, the microfluid systems can be used to test details on the design of the catheter. Other models use numerical simulation, CDF, to investigate urine flow in the standard ureter, often in combination with microfluid systems. A view to the future, an incrustation model with adaptable properties. Here an example, the Miniforce system with the bioprocess platform software Eve Premium. Here we find freely selected operation modes from closed system to open systems, continuous, and setting on the flow rate and simulation of peristalsis with the software, and the setting the properties of the medium. And what are the requirements for the test systems? The figure shows parameters that should be determined to characterize the stand, such as material, growth condition, and cells are affected. Critical factors are biocompatibility, stability, and antimicrobial activity. And here's an example of the cell culture to characterize the biocompatibility of the implants. The MTS assay is used here to test the biocompatibility of the polymer samples and evaluated variability and cytotoxicity. And don't forget the mechanical testing of the material surface of the implants, including radial compression and friction testing. And here you see further qualitative analysis, qualitative analysis like X-ray spectroscopy, you know, the infrared spectroscopy, and also the Raman microspectrophotometry. And here are some examples, the focal Raman microspectroscopy and the energy dispersive X-ray spectroscopy, and not only the FTER. As a conclusion, we need also different in vitro incrustation models with test media artificial urine based on urease reaction and on calcium oxalate crystallization, And we need models with adaptable properties for testing specific properties such as biocompatibility or samples, and also for testing prototypes. And we need models for investigation for the flow performance and models for simulating of physiological condition of the upper urinary tract. And at last, we need additional in vivo studies as a complex finally test. Thank you for your attention.